Hi, welcome to E-Content Development Center, Majlis Arts Science College, Puramannur. I'm Zanha, studying BSc Physics second semester. In this section, we're gonna discuss about energy diagram of a linear harmonic oscillator. Before we get into that section, let's begin with some basic terms related to energy diagram. Introduction. What is energy? Energy is defined as the ability to do work. In this section, we're gonna discuss about two types of energy, potential energy and kinetic energy. What is potential energy? Potential energy is the form of energy it possesses due to its position. What is kinetic energy? It is the form of energy it possesses due to its motion. In this section, we should be very aware about what is linear harmonic motion. We say a particle is in its linear harmonic motion if its magnitude is directly proportional to its displacement. It is always directed towards its mean position. What is potential energy curve? If we plot a graph connecting potential energy and its position, then it is called potential energy curve. What is the importance of potential energy curve? Normally, we have to solve equation of motion to get information of a dynamical system. That involves a lot of difficulties. Here comes the importance of potential energy curve. Just by plotting potential energy curve, even without solving equation of the motion, we can get information of the dynamical systems. Here comes the importance of potential energy curve. Potential energy is the function of X alone. Here there is a equation that connecting force and potential energy. That is F is equal to minus del U. If the force acting on the particle is three-dimensional, then the equation becomes F is equal to minus dou U by dou X I cap plus dou U by dou Y j cap plus dou U by dou Z k cap. So we learned some basic terms related to this section. Now let's move on to the energy diagram of a linear harmonic oscillator. This is the energy diagram of a linear harmonic oscillator. Here the H1 and H2 represent turning point of this motion and the E represent total energy of this function. Here this graph shows energy diagram of a linear harmonic oscillator. The H1 and H2 shows the turning point of this motion and the horizontal line E shows the total energy of this motion. Now let's learn some characteristics of this graph. The thing that we needed to note here is the slope of this graph du by dx gives the force acting on this particle F is equal to minus du by dx. The energy diagram represents the motion of a one-dimensional harmonic oscillator. The graphs are plotted as function of energy and its position. This energy diagram represents motion of a one-dimensional harmonic oscillator. This graph is plotted total energy and potential energy as function of a position. Here the E shown in the figure shows the total energy. This energy diagram represents motion of a one-dimensional harmonic oscillator in which total energy and potential energy are plotted as function of its position. Potential energy and kinetic energy are varying with respect to X or its position. So the particle will have the maximum potential energy at its extreme position. So potential energy and kinetic energy are varying with respect to X or its position. So when the particle moves from its origin either its direction, the potential energy increases and kinetic energy decreases. So the particle will have the maximum kinetic energy at its main position or at its equilibrium position, and the particle will have the maximum potential energy at its extreme position or at its turning point H1 and H2. Here the potential energy becomes zero. Here the potential energy becomes maximum. The kinetic energy acting here is maximum and the kinetic energy acting here is zero. Since kinetic energy can never be zero, the motion is constrained to a region U is less than or equal to E. That is, the motion is limited to a region in this shaded area. Now let's learn a new word, that is height of the potential well. That is the potential difference between at the top and bottom of the potential energy curve is called height of the potential well. If the energy given to the particle is less than of the potential well, then the particle will execute its motion about its mean position. If the energy given to the particle increases, the separation between turning points H1 and H2 increases. If energy E given to the particle decreases, then its turning point or the amplitude of the particle decreases. Then E is equal to 0, then the particle will be at its mean position or at X is equal to 0. The notes will be available in the description box, and thanks for watching.